already? Alright, so here's what you're gonna do. Alright? So you got always have a piece of paper that's about this size. Maybe a little bit different, but it's about this size. Alright, and carefully, I want you to tear a square out of the corner, like this. Okay? Then, I want you to tear the same size, and we're not measuring all that, but close, out of each corner. So you're going to do the same thing on each corner of your paper. And the little squares you tear out can be however big you want. They don't need to be just like mine. Taking out a square from every corner. So basically, what your paper is going to look like is you're cutting these corners out. So the paper you have left is going to look like this, right? Is it going to look like that? Okay, now I want you to fold up the flaps that you created by cutting out the corners. You made flaps. Fold those up, and you will have a little box. Right? These two boxes are a little bit different. They were made with the same size piece of paper, but they're a little bit different. Why? How come they didn't turn out exactly the same? What was different about it? The size of the corners that I ripped out. So the size of the corners that I ripped out controlled my box, the size of my box, or maybe I should say the shape of my box. So, let's let these little corners that you cut out, we'll call them X. Now, if I had a giant bag of M&Ms, and I walked around the room and I filled all of your boxes with M&Ms, would everybody's box hold exactly the same number of M&Ms? No. Some of them would hold more than others, right? I am like a freakish chocoholic, so I would want my box to hold the most possible M&Ms, right? That's our job today. We're going to take this piece of paper that's in our notes, and it is 12 by 14, and we are going to create, we're going to figure out how big the corners would have to be to make that box have the largest volume. Okay? So let's do that. Set your boxes aside. You can keep those forever if you want. It's a one and only arts and crafts project. I need to write an equation for the volume of my box, because isn't volume the word we use to describe how much it'll hold? And I want to maximize my volume. That's going to be my task here. I'm going to find the maximum. My calculator's going to help me. But my calculator can't do anything until I figure out an equation to put in. Okay? So let's talk about volume. How do you find the volume of a box? What's the formula from geometry? The volume of a box is length times width times height. So the bottom of a box is length times width times height. Okay. My piece of paper started out 14 long. So think about that. Pretend this was 14. Okay? It's not 14 anymore. The box is not 14. Because I did what? I took away two corners. I took out an X on this side and an X on this side. So it used to be 14, but now it's going to be 14 minus 2x. It was 14 all the way across, guys, but I took off an X here and I took off an X here. So now it's 14 minus 2x. What about the width of my box? It used to be 12, but didn't I take an X off each side of that too? So that's going to be 12 minus 2x. And then what about the height? How tall is my box? What is this right here? That's the height of my box. What is that? Guys,
2x.
isn't that X? Isn't X the height? Isn't that what I folded up right here, X? So my height is X. So there's the equation for my volume. Now, I want everybody looking up here because this is going to be a test question. It's also going to be a semester exam question. All right? This is the classic pre-cal problem of all time, all the way around the world. Everybody does the box problem. When I change the dimensions of my paper, and we do another problem, and the paper is 16 by 20, what's going to change in that equation? 16 minus 2x, 20 minus 2x, x. It ain't never going to change. It's always going to be that. So whatever the dimensions are, I don't know, 50 minus 2x, 40 minus 2x times x. That's going to be your volume every time. Got it? Clear? Okay. Now, I'm going to put this in my calculator in a minute. But first, I need to find out what the domain is. So this is question A. Question B says, what's the domain? Now, you know that domain involves which letter, X or Y? You can think of this as Y. X, right? Domain is X. So I want you to tell me, in this problem that we're doing right here, what can X be? Now, a lot of times we say all real numbers. Can X be every number in the whole wide world? No, because it certainly couldn't be -5, because X is this right here, right? It can't be -5, it has to be bigger than 0, okay? So my domain is going to be bigger than 0. This is going to be an interval, not an ordered pair, an interval. X is going to be between two numbers, and one of them is going to be 0. Now, is there an upper limit, or can I just keep going? Can X be 50? Why not? Because the paper is only that, it's not that big. The paper's only 12 wide, right? So is my upper limit 12? Now remember, what's X? X is the corners. Didn't I take a corner off each side of my paper? So if this is only 12 across, and I'm going to take a corner off each, they can't be 12. You can't take 12 and 12 out of 12. How big could they be? 4. How about 5? Could I take 5 off each side? Kids, my paper's 12. If I took 5 and 5 off, wouldn't that leave me with 2 inches there to make my box? It'd be a funny looking box, but I could do it. What is the biggest that I can take off? 6. Very good. 6 is your upper limit. Why is 6 the upper limit? Because it's half of 12. Now, you might be thinking, well, how come you didn't use 7? That's half of 14. Tell me, why didn't I use 7? Because I can't do 7s out of 12. I have got to take half of the smallest dimension. Because if you use the big one, you don't have enough on the small one. So half the smallest dimension. That will be my domain. Alright, so what I'm trying to get you to see is, these problems are always done exactly the same way. Our equation always looks like this, and the domain will always be 0 on the low end, and half the smallest dimension on the big end of the domain. Okay? Now I'm going to go to my calculator, because now it says find the maximum volume. So remember, we put our equation in, this is the equation we're putting in, and we're putting it in y equals. So we press y equals, and we type in the equation exactly like I wrote it. So 12 minus 2x, 14 minus, I put in the parentheses. You don't need to multiply it out. That would be a waste of time. Before you hit graph, go to window. Window. What do you think x min should be? 0. What do you think x max should be?
6.
Now, y, remember, is the volume. Can volume be negative? So 0 is y min, and then y max is going to be the answer to the question. I don't know what that is right now. So let's put in a trial number. What do you want to put in for y max?
3,000.
3,000? That's a little big. Let's not mess with that. 50? Probably too small. Let's put it in and see what happens, okay? So put in y min is 50, or y max, I mean, is 50. Now hit graph. What you see on your screen is hopefully something that looks like this. Is that what you saw?
Yeah. No.
Well, that's what you should have seen. So, what does this tell me? I'm looking for the maximum. What does that tell me? 50 is not big enough because I don't see the top of that hill. So let's go back to that and let's try 300. Now do you see the top of the hill? For y max I put in 300. Now do you see the top of your hill? Yeah. And this is the point we are looking for. So I know we did this before. We're going to find the maximum, right? So here we go. Second calc max. Remember doing this, left bound, right bound, and all that? So let's do it. Why don't you just sit here? This is the point I got for my maximum. Did anyone else get that? Mackenzie? Okay. Okay, well, there's only one maximum on the interval we're looking at. So, I don't know what you did. Your equation might be wrong. I don't know. The calculator ain't going to make a mistake. And we're going to match exactly. So you need to retype in your equation. What?
The y.
Now, here's what we need to talk about. Every time you do maximum or minimum on your calculator, you get a point. So then you have to go back and read the question and figure out which one we want. The question says, find the maximum volume. So is the volume the x coordinate or the y coordinate?
The Y.
The y. So the answer to the question is 160.584 cubic inches. Why is y the volume? Because that's the way you wrote your equation. You said y equals the volume. What would this number be? What does that tell me?
That would be,
What was x? What did x
that was
represent?
the corner.
The corners. So remember when I wanted to build the biggest box I could? I would take my sheet of paper and measure corners that were 2.148 inches. And that would give me the box with the biggest volume. All right, now we're gonna try another one. So those of you that are in La La Land, we're gonna start all over, all right? We're starting all over. We're gonna do exactly the same thing. Those of you who know what's going on can go ahead and do it. The rest of us are going to start all over.
Are we doing D?
We're doing E. Who's did E? So E is a paper that's 20 by 24. This is problem E. Same exact problem, just 20 by 24. So what will my volume equation look like? 20 minus 2x.
Doesn't matter what order you
24
put it in.
minus 2x times x.
It doesn't matter what order you put
Now,
it
we're
in.
gonna measure. Now, it does have to be 20 minus 2x. It can't be 2x minus 20. But these two can be in either order. You know, remember how you're building the box?
Oh, yeah.
We're taking the x's off, right? Yeah. All right, that's our equation. Now, let's talk about domain. Domain is going to be an interval, and you're going to put your smallest possible x and your biggest possible x. So what is always our smallest possible x? 0. You can't be negative, so 0 is the bottom one. Now look at your paper this time. What is your biggest possible x? 10. Because 10 is half of the smallest dimension of the paper, right? Okay. So now I'm going to go back to my window. Remember, we're starting over. So I'm going to my window. X min is still 0. X max is 10. Y min is still 0 because Y is still your volume. And just for fun, I have it at 300 for Y max. I'm going to leave it because it's either going to be big enough or it's not, and I'll go back and change it. So I'm just going to leave it 300. Now, I'm going to type in my equation. So go to Y equals, and type in your equation. And hit graph. Whoa, was 300 big enough? Oh, no. What did you pick, 1,000 maybe? Let's try 1,000. Oh, 1,000 works. So for Y max, I did 1,000. Are you paying attention? Why don't you type it? Could you use a number other than 1,000? Could you have used 1,200? Sure. Because the only goal is to see the top of the hill, right? So use whatever you want to use to see the top of the hill.
Can you go smaller than 1,000?
As long as you can see the top of the hill, yes.
Would it be easier if you go smaller number?
I don't know what easier is. I just need to see the top of the hill. It doesn't make a difference. I mean, as long as I can see the top of the hill, I can find the maximum. So if If you make it too big, it flattens it out, and that makes it hard to see. If you make it too small, it's gonna go off the screen. So you just wanna find a number in that shows the hill. Alright? So we got a hill. So second calc max. Where's your calculator? Who else doesn't have one? Geez, I don't want to have to do this every time. Charge.
774 16461.
Not to make you feel bad, Evan, but you're the only one. All right. So, second calc, quick message. So, second calc max. I'm gonna set my left bound and my right bound. Who has a maximum? Who found one?
774.
Well, let's write down the whole point and then talk about that one more time. So the whole point was what? 3.621, yeah. And 774.165. Now, again, you might round wrong, but your calculator should say exactly the same thing as mine. We're not trying to be close. We are going to be right on. All of us are going to. Our calculator cannot screw that up. Okay? So everybody got the same answer. What does this 3.621 tell me?
That is the corners.
The corners. So if the question said, how big should the corners be? You would say 3.621 inches. What does this number tell me?
That is the volume.
That is the volume. So since the question said, find the maximum volume in box, I'll say 774.165 cubic inches. Okay? All right. Still need your calculators. Don't put those away. Still need them. Now we're skipping down to H. Problem H is a different kind of problem. Okay? Problem H is what we call a mixture problem. So here's what's going on in problem H. I want to make some lemonade. In my refrigerator, I have a jug of lemonade from Meijer and a jug of lemonade from Walmart. And Meier's lemonade is weaker. It's only 12% lemonade, it's too watery. Walmart's lemonade is stronger, 20%. It's too strong. So I'm gonna mix those and get a nice little mixture that I like. It's kind of medium. Not too weak, not too strong, medium. Mix them together. When you do a problem like this, the easiest way to do it is take the amount of the first jug times its percentage. Whoops. And add the amount of the second jug times its percentage. So amount times percent of the first solution, amount times percent of the second solution, and that will end up giving you the amount times the percent of the final solution. Okay, so amount percent of this, amount percent of this, and that will equal the amount percent of that. So let's see how that works. How much, I don't know, X, 12% solution should be added to 18 gallons of 20% solution to get an 18% solution. Now, all I've done is plug the numbers from the problem into my little formula. I put an X here because it said how much, so I put X. Now notice, and this will always happen, there's one little thing here that I don't know. It's not filled in. Do you have an idea? Think about what you're doing. Here's my big bucket. I dumped in X gallons and 18 gallons. Not 18 times X, 18 plus X. Think about it now. If you dump in 4 gallons and 5 gallons, wouldn't it be 9 gallons? So if I dump in X and 18, it's going to be 18 plus X or X plus 18. There is always going to be one, I'll call it parentheses, that you are going to have to figure out. Most of them you're just going to fill in right from the problem, but you're always going to have to use your common sense to figure out one of them. All right, let's go ahead. So 0.12x plus, use your calculator, and then this is going to be a distributive. Make sure you're doing distributive there.
I'm a little confused how you got the 18 plus X. Like how, like, where's the 18 come from?
It was this 18. I'm mixing 18 gallons and X gallons.
Oh.
Read the problem. I have X gallons in this, 18 gallons in this. I'm gonna end up with a total of 18 plus X. All right. Is that 3.24? So all my percentages, just like yesterday, all my percentages are going in as decimals, just like what we did yesterday. And now I have an equation to solve. It's hard to imagine this, but it happens all the time. When we go to solve this, what do we get when we subtract 0.18 minus 0.12? 0.06. I got 6. And the unit was gallons, so 6 gallons. Anybody else get that when you solve the equation? So the question said, how many gallons of 12% should I put in? 6 gallons of 12%. Okay. Let's look at problem I. Alright, let's all get on the same page here. Let's all start with problem I. Same kind of thing. First of all, when you read it, can you see it's the same kind of problem? Okay. So, let's start filling stuff in. percentages that you have to fill in. How much? All right, let's go with X there. The amount, how much? 22% should be mixed with 74% to get 100 gallons of 50%. Now, do you agree with where I put my numbers? Amount times percent of the first solution, amount times percent of the second solution, and then amount times percent of the final solution. Now, do you remember what I told you? I said every time you do these, every time, you're gonna have an empty parentheses. And you're gonna have to figure out what goes in. Now, do you notice that the empty parentheses is in a different spot this time? Last time it was 100 plus X. Do you think this is gonna be 100 plus X? No, 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 no. Because these two added together have to end up being 100. So X plus my empty parentheses has to add up to 100. Does that make sense to you? The amount is X, the amount is an empty parentheses, the final amount is 100. So these have to add up to 100. So what's that parentheses gonna be? Solve this. What's it gonna be? Get this by itself. What are you gonna do? Subtract. So what goes in this parentheses? 100 minus X. Bingo. Bingo. In our first example, it was X plus 18 equal to parentheses. So the parentheses equaled X plus 18. But this time, X plus the parentheses is 100. So the parentheses has to be 100 minus X. All right, now we start solving. Our distributive is right here. Make sure you're distributing. Before you do much, should we combine by terms here? We didn't have to do that the last problem, but we did this time. So what is that? Point negative 0.52x?
Yep.
Let's see what we come up with. I got 46.154 gallons. Yep. Everybody get 46.154?
Yep.
Now, you ready for the good news? We're skipping J and K, just cross them off. We have enough different kinds of problems to keep us busy. Okay? So, here's what we're gonna do. I'm gonna basically we have, 4 kinds of word problems, alright? So I'm gonna put one of each. I don't have time to do all 4. Let me put a couple up here. And then I'm gonna hand out the practice test. While I'm doing that, I want you to be working on these 2 problems I'm putting up there on the board. So one of our problems was, that a jumper $11.25 last year. It costs, let's say $12.36 this year. Find the percent of increase. We did this yesterday, look in your notes, it was right. Find the percent of increase. The second one I want you to be looking on is, the jumper costs $12.36. I have a 16% coupon. And I live in a state that has an 11% tax. Find the total cost of the jumper. Okay, so work on those two while I get your practice tests to distribute.
Thank you.
Okay, let's see how far you got with these guys. All right, how do we find a percent of change, whether it's increase or decrease? What do we do? What's our little formula? All these things have kind of like formulas with them. What's our little formula for percent of change?
The
Difference over original. Kids, that's it. That is literally it. So find the difference in the prices. I got $1.11. And then which one is my original? The first one that came up, and that's 11.25. So when I do that division, did you get a 9.867% increase? The decimal actually comes out, it'll always be a decimal, comes out like this. To get a percent, you have to move it 2 places, and then we're gonna round it however we're told to round it. When we're not told, we usually use 1,000, because that's what AP does. Okay. All right, everybody good with that? So easy. Now, I go to the store, I'm gonna buy that jumper, I got a coupon, I gotta pay tax. So I'm gonna start always with the price. And then every other part of the problem gets a parentheses. And the parentheses is either gonna be 1 plus the percent or 1 minus the percent, depending on whether I am adding on to the cost or taking away from the cost. So what does a coupon do? Take away. So I'm gonna take 1 minus 0.16. So what goes in here? 0.84. Now, what does tax do? Add on. So that's gonna be 1.11. And I just multiply it all together.
11.52.
And this, I round off to the nearest cent, right, because it's money. So yes, $11.52 is what I would pay for that jumper. All right? So real quick, we can do one more of our problems. Let's do a mixture. How much 92% solution should be mixed with 4 pints of 50% solution to get a 63% solution? So I got a strong solution, I got a weak solution, I'm mixing them together to get a medium solution. What is my setup, my general formula for this problem? Amount times percent plus amount times percent equals amount times percent. So amount, percent, amount. So, look at my first thing. How much 92? So x 0.92. 4 pints of 50. 4.50. And I'm ending up with a 63. Now look at your amounts. You have x, you're adding 4, and you're equaling something. 4 plus x, or x plus 4, it doesn't add, it's the same thing. These two are adding together to get that one. Alright? Don't have time to solve it probably, but you know what to do from here. Always a distribute, always a distribute. I will see you tomorrow on Monday. We will do a little practice with a word problem. Then we'll have a word problem quiz. As we are reviewing for our
Why did you do that?
At the end of the day, let us pray and work off the day.